Lesson 1.8, Solving Simultaneous Equations by Elimination. This is very easy when one of the variables, x or y, has a coefficient of the same magnitude or size. For example, in this equation, the coefficient of y is 5. It's positive 5 in the first equation and negative 5 in the second equation. The variable has a coefficient of the same magnitude. We begin by labelling our equations. Equation 1, equation 2. I now can ask myself whether by adding or subtracting the two equations, do I eliminate the y variable? The answer in this case is that if I add equation 1 to equation 2, I will eliminate y. 3x plus 1x is 4x. Positive 5y plus negative 5y is nothing. And negative 3 plus 19 is 16. This then becomes very easy to solve. We know that 4x is 4 times x, so I can divide both sides of the equation by 4 to get the answer x is equal to 4. This is only half of the solution. I now need to find y. I choose either equation 1 or 2, whichever looks easier. In this case, I'm going to choose 1. 3x plus 5y equals negative 3. I'm now going to substitute for x the value that I know x is, which is 4. 3 times x plus 5y equals negative 3. 3 times 4 is 12, plus 5y is negative 3. I now need to undo the positive 12 by subtracting 12. 5y equals negative 15. Divide both sides by 5. And I can see that y is equal to negative 3. The solution to this equation is x is 4, y is negative 3. I can check this solution by substituting it into the equations to see if it works or satisfies the equation. The equation x take 5y equals 19 would become x 4 take 5y equals 19. 4 plus 15 equals 19. 19 equals 19. I now know that the solution, negative 4, negative 3, satisfies the equation x take 5y equals 19. I could check my equation by substituting 4, negative 3 into the second equation. I would find that it also satisfies the equation, reassuring me that my answer is correct. Can I solve a simultaneous equation if they do not have a coefficient of the same magnitude in front of each variable? The answer is yes. 3x add 2y equals 5. Solved simultaneously with 4x take 3y equals negative 16. This can be done. I label the first equation 1, the second equation 2. I note that if I multiply equation 1 by 3 and equation 2 by 2, I will end up with a magnitude of 6 as the coefficient of y. Multiplying equation 1 by 3 gives 9x plus 6y equals 15. I call this equation 3. Multiplying equation 2 by 2 gives 8x, take 6y, equals negative 32. I call this equation 4. If I now add equation 3 to equation 4, I will eliminate the y variable. 9x plus 8x is 17x. Positive 6y add negative 6y is nothing. 15 add negative 32 is negative 17. To find x, I divide both sides by 17, which will give me a solution of x equals negative 1. Remember, this is only half of the solution. I now need to substitute x equals negative 1 into either equation 1 or 2 to find the value of y. Substituting into equation 1 gives 3, x we know is negative 1, so 3 times negative 1 plus 2y equals 5. Negative 3 plus 2y equals 5. Adding 3 to both sides of the equation gives 2y equals 8. Dividing both sides of the equation by 2, I can see y equals 4. Hence, the simultaneous solution to the two equations is x equals negative 1, y equals 4. Please remember that you can substitute this solution into both equations. If it satisfies both equations, you know your answer is correct. Please now go to page 54 and 55 of your text and complete questions 3 and 4.